Okay, so this is where we are. So we've done that. Thank you. Whoever sent that message. So yeah, we have 23 people. Maybe we should give it a 1 or 2 minutes and then.
Yeah, I mean, I think we're still within discretionary time, I believe. 7:59 here. Maybe 2 more minutes and we can kick it off.
Okay, I'm going to open my window, sip on my coffee. Okay. Try to wake up this Sunday morning, Sunday afternoon.
Okay, is this your first in the series?
Let's see. I did session 2, so no.
Okay.
Yeah.
So that's the session on t-test. No, t-test was Bucci.
Bucci, yeah. You know, I'm wondering that I don't know how possible it would have been for me to teach the t-test series because it feels like it feels a little technical. The t-test and an ANOVA a little seem to me a little more technical to teach even than a regression, but I don't know, who knows.
I mean, I think from the standpoint, of the fact that we're teaching much more on a conceptual basis than the underlying statistical theory. I mean, I think it's almost the same.
Okay.
I mean, from a theoretical viewpoint, I think it's so the t-test is a steeper, there's a steeper learning curve,
Right.
Yeah, but once you get to the t-test and you're comfortable with the t-test, because people are very familiar with this, equation for a straight line, much earlier on, that's not complicated algebra.
Right.
Regression kind of resonates a little bit easier.
I hope
you're not doing a lot of theoretical.
Yeah.
If you're not, delving so much into the underlying statistical theory.
Yeah. Yeah.
Okay. So I think there are 44 people here. So maybe it's time to kick it off.
Okay, let's kick it off. Hello, everyone. My name is Abua, and I will be your tutor, facilitator for today. Today, we're going to be learning linear regression. My style of teaching is quite interactive. And so what I typically would do is ask people to volunteer by raising their hands to join what I call a panel. And we would take about 5 to 7 people who would be on the panel, and then they would help us answer questions when I ask them, and they would have that discussion as we go on. And the reason for that is this: if you see that your peers or your classmates or your group mates, okay, I see someone's raised their hands, Abdurrahman, please let's unmute Abdurrahman and let's have him join the panel. When you see that your peers or your classmates know or understand the things that are being taught, then you understand that it is not something that you cannot do. It's actually based on behavioral theory. So I think it's a good way to go. So there are 53 people at this point. So if 7 of you can raise your hands, then we can start. So let's give it 1 more minute. I think only 1 person has raised their hand so far. Okay, 2 participants raised their hands. 3, oh, okay. So let's unmute them or give them the ability to speak. 4 participants. Now, how do I see the people who, let's make sure, how do I see the people whose hands are up? participants. Okay. So I see Somtochukwu. Oh, by the way, I'm looking at two screens, so if I'm not looking at you.
Yeah, both of them have permission to speak. Somtochukwu and Abdurrahman. Both of them have permission to speak.
4 people raised their hands so far. So where are those people?
I said just 2.
Okay. Okay, so well, it's saying 3 participants. Okay, there's Ebube Umeji and Dr. Oroma Kinde and Badru Lawal. Okay, nice. Okay, so let's go. So today we're going to be doing linear regression. And if you joined the panel earlier, or the Zoom earlier, you'd have heard Dr. Omotayo talk about regressions being a straight line. And okay, let's go, and then I'll make my jokes as we go along. So here's the outline. We're going to be talking about Pearson correlation, and then we're going to be going into simple linear regression subsequently. The reason why I was talking with Dr. Abioye, and he said, the reason why we want to talk about Pearson correlation is this. When you look at papers from Nigeria and from other parts of Africa, what you see is that researchers would conduct a Pearson correlation, and that's the end of the statistical analysis. And he believes, and I agree with him, that we can do a lot better. We can go beyond a correlation and into linear regression and even beyond that. And that's why we're doing what we're doing at Stats Clinic. We want the researchers to have the knowledge and the capacity to do in-depth research. Okay, I told you the last time I was teaching this that I had a friend who, during his residency, he told me about his paper that he wrote, his dissertation. Please mute yourself if there's noise in the background until you're called to speak. So Somto, I think you're, or Lawal Badru, I think that you have noise in the background. And this fellow was telling me about all the lovely things that he did, a histogram, a box plot, a pie chart, you know, and I was like, oh yeah, fantastic, amazing, you know. But the truth is, at the level of writing your doctoral dissertation, even if it's in clinical medicine, you should go beyond graphical representations of data, the box plots. And so I'm telling you this because I want you to get challenged. I want you to open your mind. I want you to, after this, read up some more so that you are much better, much skilled at doing this work. So let's start with correlation. And so let me ask Badru Lawal, can you unmute yourself? If the price of cement in Sierra Leone, for example, goes up, what can we say, to the best of your knowledge, about what will happen to the price of building a house?
You said if the price of
cement,
what goes up,
cement.
It's going to be, there's going to be correspondence increase in the price of building a house.
All right, so that's the exact definition of correlation. That when one thing changes, the other, there's going to be a change in the other. And I don't know the meaning of corresponding. I don't know whether it means that the same amount of change in one will lead to the same amount of change in the other. In correlation, that's not the case. So if the price of cement increases by 50%, the price of housing may not increase by 50%, but we are certain that the price of housing would also increase. That's exactly what correlation is. Okay, so Lawal, you're still answering the question. So let me ask another question. If a person reduces the amount of calories, if the person reduces the amount of if a person increases the amount of healthy food they eat, what will happen to their BMI?
It will lead to reduction in BMI.
All right. So in the first case, you see that when one increases, the other increases. In the second case, when one increases, so you increase healthy food, the other reduces. So a correlation doesn't, we've established that a correlation is a change in one brings about a change in the other. But I don't want you to think that the amount of change, 50% of the change in one will lead to 50% change in the other. That is not a correlation. The second thing we've established is that it does not matter the direction. So in one case, increase creates increase. In the other case, increase creates decrease. That is still a correlation. The fact that the directions are different does not make it not a correlation. Okay, so that explains very simply what a correlation is. If a change happens in one, a change will happen in the other. But there are two properties of correlation, as you can see on the screen, is the direction, and we've just talked about the direction. So if the price of cement increases, the cost of building a house will increase. That's direction, and some people call that a positive correlation. You see, so increase. If one increases and the other decreases, some people call that a negative correlation. So, but there's also the idea of strength. So how strongly? So remember that we said that it is not, a correlation does not have to be equal magnitude in increases. However, there can be, let's use this example of cement that we're talking about. Just because the price of cement doubles, it does not mean that the price of housing would double. There are other ingredients used to build housing. And so a double price in cement may lead to only a small shift in the price of housing. And so maybe you would call that a weak correlation. If you remember your economics, people will talk about elasticity. If something moves a little, then the gap is wider, blah, blah, blah. There's also, in correlation, there's also the strength. That if something changes only a little bit, and the other thing, if something changes a lot and the other thing changes only just a little, you might say that the correlation is weak, and vice versa. So there are two things that you look at in correlation. Is the direction and the strength. Now, let me tell you a third thing that correlation is not. So we've talked about a negative correlation. The fact that a correlation is negative does not mean that it is weak. And we're going to see it in the next slide. So a negative correlation might be negative 0.8. That does not make it a weak correlation just because it is negative. We're going to talk about the strength of correlation further. But before we move from this slide, I'm going to recap what I just said. Correlation means when one changes, the other changes. We also said that there are two things that you look at, a direction and a strength. In direction, it means that both of them can increase together, or both of them can change in an opposite direction. That's positive and negative. And then we talked about strength, and we said the extent to which the changes occur when change is activated in one is the strength. And the fact that the strength, a correlation is negative or positive does not make it strong or weak. Okay, so in statistics, when you conduct a correlation test, you are measuring the correlational coefficient. That's what is here. It is captured as R, if it's a sample, or it's captured as rho. Rho looks like an italicized P in when you're looking at the population. So remember from past lectures, we talked about when you use Roman numerals, that's your A, B, C, D, you're talking about samples. But when you use Greek numerals like rho, sigma, beta, you're talking about population measures. And this becomes important when you see the output in data. Okay, someone raised their hand. Do you want to ask a question? And by the way, you can type your questions in the chat and Dr. Motayo will either respond to them via chat or will bring them to my, will bring them and say, oh, Ebua, someone has this question, you can help answer that. Okay, so if Toluwani, do you want to ask a question?
Okay. Sorry, that was a mistake.
Okay, that's fine. That's fine. Okay, so now let's look at what we've been talking about pictorially. Can you, Toluwani, since you are there, help me answer this question. If you can unmute yourself, or if you're no longer there, let's call on Dr. Oromakinde. If you unmute yourself.
Here.
Oh, you're here, good. So tell me about the direction of the correlation. I wanted to ask you if there's a correlation in the graph on the left, but it already says positive correlation. So tell me the direction of this positive correlation. And you can say it moves from the top left down to the bottom right, or it moves from the top right down to the bottom left. That's what I'm asking you to tell me. So hit me.
I think it's top right to bottom left.
Top right. So can you see my cursor, my pointer?
Yes.
Okay, so you're saying top right. So it moves from here and it goes this way.
Yes, I think so.
You think so? That's good enough. So can we have someone else, Dr. Romakinde, or if we have someone who disagrees, unmute yourself and tell us. But Toluwani, you still stay on the line because you answer other questions. Okay.
Excuse me, I think it's spreading from bottom left.
Bottom left, okay.
To upper right. It's
all right.
Kind of spreading.
Nice. 2 ways to kill a cat. So both of you have actually said the same thing, right? But Toluwani looked at it from top bottom and you looked at it from bottom top. But what you said, when we talk about homoskedasticity, it's a big word, I know. But next week, I'm going to talk about homoskedasticity, and what you just said will become important. So keep that in mind. Toluwani, let's come back to you. What about this? It says no correlation, but look with your, what people call your church mind. Look with your church mind and tell me what the direction here is.
I think it's top.
Okay, that was a trick question. There is no direction. There is no direction. Now, something that I want you to note, we've been talking about p-values. Okay, let's skip that. Look at the p-value here, it's statistically significant. And look at the p-value here, it's not statistically significant. Okay, so keep this in mind. So you're looking at the correlation. We talked about direction, we talked about strength, but you can also see that you can look pictorially and you would say, okay, I see, this is correlated. This looks correlated. Very much like your scatter plot, not scatter plot, box plot, or your histogram. Okay, so look at this one. Let's have Ebube Umeji. What do you think about this? So we've talked about direction in this slide, but now we're going to ask Chief Ebube to tell us a little about this. So let's forget about, can you unmute yourself, Ebube? So don't tell us, I think Hakim raised his hand. If you have a question, you can type it in the chat. If you want to join this panel to answer questions, just wait a little bit and we're going to rotate the panel from time to time. So Ebube, why don't you tell us, we know the direction. I mean, this looks like a shooting star up. Or if you take Toluwani's style of thinking is going down, you know, but the direction, we know what direction it is. Tell me about the strength. What do you think about the strength here? I know we've not covered it, but just using your, your idea. And I see that Abdurrahman, you raised your hand here on the panel, so talk to us. You can help us. Ibube or Abdurrahman Olamilekan. What do you think about the strength here?
Good evening, everyone.
Hi.
Can you hear me, sir?
Yeah, go ahead.
I can hear you pretty well.
All right, thank you, sir. Thanks for giving me the opportunity. My opinion on the strength here is that it is positive.
Okay.
That is a positive relationship between the two variables.
And what do you think about the strength? Is it the strength that you think is positive?
The direction. The direction is what.
Yeah. We talked about direction here. We've already looked at direction, so that's kind of clear. Now we want to talk about strength. What do you think?
Yes, the strength is also positive as well, because an increase in one will also increase.
1 second. Remember what we said, correlation is not. You cannot talk about the strength of a correlation because it is positive or because it is negative. The direction has nothing to do with the strength. Okay. Right. So let's Dr. Oromakinde.
Dr. Ibube.
Okay.
Can I speak?
Yes, please.
Okay. From what I'm saying, that's the first one. I think it has a strong correlation because this area increase. So I think it has a strong correlation.
Because
an increase, if you look at both the coordinate, X and Y coordinate, an increase in one results to a similar increase in the other, and it's quite linear. It's going forward. So I think it has a strong correlation.
Okay, good. So let me also tell you another thing that a correlation is not. Yeah, sometimes you can have different scales. So you can see that this is SBP and this is also SBP. But imagine if it was SBP and money. You cannot say that the scale that an increase in SBP has a similar, from what you just said, there's a similar increase in the scale in the x-axis as in the y-axis. What if those axes are radically different? What if this was SBP and this was blood sugar? Then it does not make any sense to say because the increases are similar, then it must be strong. But you're onto something. Now, when you look pictorially, remember that on this slide, we talked about direction. We can see that there's a direction here. Here, there's no direction. It's random. Here, when you look pictorially and you want to think about strength, if you draw a straight line, for example, if you draw a straight line from this curve, it will follow my cursor. And that straight line, if the points are closely surrounded around that straight line, pictorially, you can say this is a strong correlation. So Dr. Ibube, stay on the line or keep on muting yourself and look at this correlation here. What's the direction and what is the strength?
Thank you. Going by what she just taught us now, if I draw a straight line, I think there will be so many things, as in so many of the points will be scattered at either side of the line and they'll be wide apart. So I think this should be a weak correlation.
Nice. You've gotten it. What of this one?
Okay.
So what's
this
the direction
one?
Of this one, before you get there, what's the direction of this one? I think I may have shown you now, but what's the direction?
Okay.
Is it possible?
This one is going from the top left to the bottom right.
So it is positive or negative?
Yeah, it's a negative.
Okay, you're on a winning streak. What of this one?
Okay, this one is positive correlation. Nice. This one is positive. And also the strength. I also say the strength too is weak.
Right, but it is stronger than this one at the bottom.
Yes,
right?
it's stronger. Yes.
So you get it. I'm going to pause here and maybe look at the chart. Is everyone following along, or do you want us to maybe do, okay, I see people giving answers, direction is negative, nice, people are getting it. Okay, so you see why I said if you have a panel, then we move along better. So let's move on. Okay, so now let's talk about numbers. Well, let's do a quick example now. And so we're back to this idea of cement. The price of a ton of cement is correlated with the cost of building homes. You've agreed. So let's say our correlation is negative. And by the way, remember negative, in mathematically, you denote it with this minus sign, negative 0.75. So let's call on somebody else. We've had Badru, Lawal, we've had Dr. Ebube. Let's have Somto, Abbas Musa. Let's have Abbas join the panel. But let's, Somto, do you want to unmute yourself? And let's ask you a question that we've not covered.
All right, no problem.
You are muted. So if the correlation between the price of cement and the price of building a house is negative 0.75, tell us three things: the direction, the strength, and tell us the implication. And let me talk a little about implication. So my school of thought is that research science, especially in public health, is for decision making. Some people think that science is just to add to the body of organized knowledge. That's good. But in the real world, because resources are limited, you must do science to further humanity. And you can only do that or further a population. And the only way you can do that is if you are making decisions. So when you're doing science, whenever you find something insightful, you must think about the implication. So going back to the question, you're going to tell us direction, strength, and the implication. Okay, talk to me, let's go.
Okay, so the direction would be negative.
Okay, why?
Because it is, the sign says negative, so that means to be going from...
Because there's a minus sign. Okay, let's move on. The strength. Okay.
The strength would be above average, about 75% correlated.
No. Don't,
okay.
Let's not get there yet. Look at this table here.
Okay.
And tell us.
Okay, so the strength will be strong. That means it's strong.
The strength is strong. So another thing, correlation is not. I don't want you saying the correlation is 75%. Talk about correlations in decimals. It's 0.75, so it is strong. So let me tell you something a little bit about this table before we talk about implications. You see, this table is not hard and fast. Some people will tell you that even though there's a 0.25 correlation, you see, I have no correlation here. Some people will tell you there is a correlation. In fact, my advisor would see a 0.4 correlation and say, this is a strong correlation. And why would she say this is a strong correlation? She'll say it's a strong correlation because anything greater than 0.5, 0.6, you're probably measuring the same thing. And that is very insightful. So some people will say, okay, how much money do you have in dollars? What's the correlation between how much you have in dollars and how much you have in pounds? And the answer is you're measuring the same thing, because a person who keeps money in dollars, why not? He would also likely to keep money in other currencies. So you're really measuring the same thing. So this is it's kind of arbitrary, but this is what we use. In fact, some people say 0.8 here, etc. So Somto, and pardon me if I'm not calling your titles, I'm just calling your name as I see it. Tell us about the implication of this, if you waste government money or you spend government money wisely to find that there is a correlation between cement and the price of building a house. What would be the implication?
The implication, since the negative correlation, the implication will mean that they are moving in the opposite direction. So when the price of cement increases, the cost of building a house reduces. That's what
you tell government what. So that's what you just said is an insight. You need to talk about the implication. And remember,
so the implication for government will be that it will cost us, the cost of building a house for us will reduce as the price of cement
telling
increases.
us the insight. You tell us implication. So you will tell the government that if you want more people to build houses, increase the price of cement. Implication. What is the implication? And I know that this is a joke, right? But let's imagine that the sign was positive. You would say, government, if you want to solve the housing shortage in this country, reduce the price of cement. That is what you say. And you say why? Because our study has shown that there is a very strong correlation between the price of cement and the price of building a house. Don't worry about steel rods, don't worry about nails, don't worry about timber. Focus on the reduction of cement. That is what we talk about when we are saying implication. Insight, it must be insight and implication. And I've said this before, public health science is really population health science. And so these things that you're learning can be used not only in public health, but in your everyday conversations. Okay, so I will turn this over to Dr. Omotayo. Can you run the poll? I don't know how to.
That's okay.
Okay, so let's take this poll. I'll look through the chat while we're doing it and see if anyone has questions.
How long do you want the post to last?
Let's do 1 minute.
So guys, can you see the poll now?
I can see it. I don't know if other people are seeing it. And Abbas Musa has raised his hand. I think he wants to join the poll. So let's add him to the poll. And if there's anyone who would like to be taken up, not the poll, sorry, the panel.
The panel, okay.
If anyone would like to be taken up the panel, feel free, you can indicate. Okay, so we're looking at answers. We're looking at things are changing. Wow, real time, this is lovely. Okay, increasing taxes of tobacco and reduction in lung cancer. I like this. This is from Onyegiri Shuku Ebuka Udo. That's a lovely real life correlation, and we've seen it especially in the Western world. It's crazy in Nigeria. Okay, if I tell you this story, it will tell you whether I smoke or not, so don't worry about it. So someone said, thank you for the clarification. The implication is that people will be out of homes. Okay, I like that one. It's Ibrahim Balarabi Usman. And negative, someone gave the answer. Okay, are we at 1 minute yet?
So we're past a minute, but I'm just gonna wait till we're at 2 minutes just to get more responses in.
Okay. Yeah, I really like that idea about the person who gave that lung cancer and smoking. So maybe in future iterations of this class, we would have more public health examples, but non-public health examples are also okay, because like I said, these population health really is critical thinking for population health. And critical thinking is a skill, whether health-wise or not. Okay, so I think we're good, and the reason is because we're going to dwell a little on this. I'm going to ask someone who, okay, let's look at the answer. Let's look at the, can we share results?
Okay.
Share, okay, I'm just going to close this. So we have 63%, and then we'll move to the next. Okay, so 63% of people chose a correlation of 0.4 between interleukin and ferritin is a weak correlation. And 17% chose, or the remaining percent did not either get the answer or they chose B. Can someone who chose B tell us why they chose B? Can you, if you raise your hand, type it in the chat. Anybody? Feel free.
Hello.
Yeah.
Hello.
Yeah, go on.
I actually chose B. So I was like, based on this, based on the question, I do look at it. If there is a weak correlation between the cytokines and hematologic biomarkers, then the relationship should not be considered important.
Oh, nice.
That's what how I looked at it. But having a second thought after choosing the option, I noticed my answer should have been A.
Okay. So, is there anyone else? Anyone else that chose B? Thank you for that. Josephine Banjo raised her hand. If we can get her to unmute herself, let's hear why you chose B, and then we'll talk a little bit about this table and something I had said earlier. And I think we're in a good place to move into regressions. I did, but the answer is A. Okay, we're looking for people who chose B and tell us why. So Monday Olodu, Josephine raised her hand again. So Dr. Motayo, I think she's persistent. Can we give her the opportunity?
No, I think she has the right. She's allowed to speak. Though.
Okay. So you can speak, Josephine. I think you've been unmuted. Okay, let's move.
Sorry, can you hear me now?
Yes, please.
Yeah, we can hear you now.
Okay, sorry about that. So at first, I picked is more important because if you look at the question, I thought, okay, sorry, it says a weak correlation indicates the relationship is more important. So I was thinking that, you know, if the relationship is not significant, that's what I thought. Okay. That if it's not significant, you know, that means it's not that important. It's like, for example, like if the relationship between the tobacco and the lung cancer was not like a strong correlation, I'll be like, oh, it's not really a factor the government should consider. That's how I look at it as. That's why I picked
about implications, and that's very good. Okay, so let's go back here and remember when I said that this table is really arbitrary. This is what people typically do, but then I also told you that my advisor or my former advisor would say that even if we see a correlation of 0.4, we would take it as strong. And then I probably told you, maybe I did not, that when we look at biological, and I had this discussion with Dr. Bioy yesterday. I said some people might consider B the answer as well. But when you, and he said to me, when you look at biological markers, most of them are actually weakly correlated. And yes, I did say it earlier. Biological markers are weakly correlated, but we cannot say they are not important. But another point you raise is this. A thing may be statistically significant, but may not be clinically relevant. So let me give you an example. You're taking this drug for your hypertension, and you pay, I'm just going to use dollars, just to standardize. You pay maybe $10 for the drug per month. And someone comes and says, there's this new drug, it's amazing, but it's going to cost $50 per month. And then you try it out. It reduces your blood pressure, but it only reduces your blood pressure significantly, statistically significant reduction of 2 millimeters of mercury. For those of you in healthcare, even though the reduction is statistically significant, a reduction of 2 millimeters of mercury is not clinically important. So when you go to implications, so the insight is that it reduces your blood pressure statistically significant. But the implication is that for a $40 increase, a reduction of 2 millimeters per mercury is a waste of resources. So remember that your research is for decision making. So if you were the healthcare administrator in a hospital, you would tell your procurement office, Do not buy that new drug. You will tell your cardiologist, do not prescribe that new drug. I'm introducing you to the field of health economics, hospital administration, decision science, because healthcare research, in my opinion, is for decision making. There's no reason for you to be doing research that does not have implications.